Hello, physics world of period G. My name is Dr. Leo Marvin, along with my partner in crime,
Dr. William Shizzzzzzner.
So, Dr. Shizzzzzzner, what exactly are we doing here today?
Well, Doctor, I just wanted to ask the class a quick question.
What's that?
How many of you guys in this classroom today have played the sport of basketball? Go ahead and raise your hand so I can get a good, clean look at you. So how many of you really know the game? I mean, really know the game.
That's what I thought. So go ahead, get comfy and relax, because we're about to get to the ball of things.
So let's get it on.
First, we're going to be going over spin on the ball. Spinning the ball when you shoot is not done to affect air resistance or to make air resistance cause the ball's path to curve, as in the case of baseball. Basketballs move too slowly for that to happen. Once the basketball leaves the shooter's hand, it travels in an unchanging parabolic path. So what's the purpose of backspin? Backspin on the ball is used to help it to bounce into the net when it hits the rim. It will usually hit something, unless the throw is very high. The backspin after contact with the back rim or board will result in a change in velocity opposite the spin direction, changing an equal angle rebound into a velocity more toward the net. This makes it more likely that the ball will go in.
Like this.
And there it is. Next we'll be going over receiving a pass. The impact of a hard pass can be lessened, making it less likely that the ball will knock the wind out of you if it is caught onto the body. The ball coming at you has momentum, m times v. By increasing the time over which you decelerate the ball, you lessen the force. In other words, since m times v equals f times t, then f equals m times v divided by t. Increasing t causes f to get smaller. This is the same principle that makes an airbag in your car work. The time over which you decelerate is lengthened, resulting in a lower force. Of course, catching a ball onto your chest has other benefits. It makes it less likely you'll drop the ball and harder for someone to grab it. Thank you. A player's shoes must have good traction.
You're horrible.
Which is the same as saying that the coefficient of friction between the shoe and the floor must be high. Friction is the force that opposes the motion of two surfaces that are in the contact. Every surface is rough on the microscopic scale, and when two surfaces come in contact, the high points on each surface temporarily make contact. The opposing or attracting forces of the surface molecules cause a frictional force. A basketball player will also make the use of static friction. A foot firmly planted rather than slipping across the floor will provide more friction when he has to stop or turn suddenly. This is because static friction, or pushing off, is greater than sliding friction. It is also why shoes must have a good grip on the floor in any direction you push off from, and why some shoes are unsuitable for basketball. They may have lots of forward traction, but slip too easily when pushing sideways.
Not these ones. These ones are good.
You heard it. Pro basketball players seem to float in the air while they're at the basket with the ball. Of course, this is just an illusion. They fall at the same rate they rose into the air, assuming they don't make contact with anything. What makes the time seem longer is probably because after their bodies reach the highest point, they extend their arms upward, giving the illusion that they're going up. They're also moving forward when they jump, which also affects our perception of time. Oh, hi there. I'm just playing with my ball. You know, we're now going to go over the bounciness of the ball, or the coefficient of restitution, should I say. That is how much the ball will bounce. The bounciness, or coefficient of restitution depends on how much air is compressed into the ball. When air is compressed, when you throw it down, the air molecules inside the ball want to push back, and hence why it bounces.
Hi, and welcome to this beautiful location. The next activity we are going to do is we're going to measure the ball at a height of 72 inches, or aka 6 feet. And then, after that, we're going to measure the bottom height of the ball and the top height of the ball. And then, what our plan is going for, we're shooting for, we want to get the ball to bounce between 49 and 54 inches. Show. Peace out. Now we are going to measure the bottom half of the ball when it bounces back up. So let's give it a try.
We're dropping the ball at a height of 72 inches. (42 inches). Now what we're going to do is measure, when we drop the ball, the top of the ball. And what we're going to do is divide the bottom half of the ball from the top half of the ball in an equation and get that, and then and then we will get the square root of that number.
So let's give it a try.
So now the top of the ball.
What he meant to say is 52 damn
52
inches.
inches. So as I said, you divide the bottom number from the top number and then get the square root of that number. And that's your coefficient of restitution. What we're now going to do is go to our correspondent, Dick Murphy, who's also going to try the same exact experiment in his home in Pennsylvania. Dick?
72 inches. The top of the ball bounced at 52 inches, but to keep things consistent, we'll take the measurement from the bottom of the ball, 42.5 inches. Now we'll put all those numbers into an equation that looks like this. You just take the height the ball bounced to, divide it by the height we dropped it from, then you take the square root of that number, and you get the coefficient of restitution.
Well, that pretty much sums it up for us here in the studio. I had a blast. What about you?
It was an awesome day.
Well, that's pretty much it. So we hope you learned a lot from this video, and we hope you now know more about the game of basketball.
So all of us from the studio, peace out. Hi, what we are no, don't do it. Hi, what we are going to do now is we're going to measure the ball at a height of 72 inches, or could I put it 6 feet. And then what we're going to do next is we're going to measure the top of the ball when it bounces and the bottom of the ball at the same time. Hi, now what we are going to do is we're going to measure the ball and wait, not that. Hi, and welcome to this beautiful area. What we're going to do now is we're going to measure the ball at a height of 72 inches. Hi, and welcome to this beautiful location. Hi, and welcome to this beautiful location. The next activity we are going to do is...
Now we're going to measure the top of the ball when it comes back up. Remember that number, kids, 52.
Let's try that one more time.
Nope. Nope.